On Screencastify today. All right, guys. So if you're gone today, great. We'll Screencastify. Not great that you're gone, but we're going to cover you. We're going to make sure you understand what we're going to do. And then if you're here, then you can watch it again. If you're having insomnia and you need to sleep at night, you could watch this and it'll put you right to sleep. Okay. All right. Let's see here. Let's pull up this here. And okay, so Esme did a really good job of reminding me that we need to go over the homework, the second part of Delta Math. So guys, you can't, but let's just put this in our notes or whatever. So you cannot I cannot overemphasize how important the Pythagorean theorem is. Okay, it's really, now with a lot of, we don't have enough of the background behind it, but that's how we know how tall Pike's Peak is. A right triangle, it's called triangulation. No one has ever measured the distance from the Earth to the sun with the measuring tape. No one's done that. It's all about right triangles, okay? That's how we know right triangles. It really is the most important concept in all of math. Now, there's so many different applications of it. So remember, guys, the Pythagorean theorem says this, and it's more of the converse of the Pythagorean theorem rather than just the Pythagorean theorem itself. So if you have a right triangle, so let me, and I'm just going to put the right triangle in just kind of like standard form, like standard position here. So we got this right triangle right here, okay? And then so we'll put that right angle in the corner. So you probably want to write this down. Now, just the straight up Pythagorean theorem. So a couple things about the Pythagorean theorem. If this corner right here, this corner is usually always C. The right angle is always C, capital C. And a lot of times this side is little c. So little c stands for the side, entire side. Big C is the point. You guys understand that? Capital C is the point. Little c is the side. So notice, guys, little c lies opposite big C. You guys see that? So if this is a big B right here, what can we say this side is right here? This is little b. And if this is big A up here, what's this side here? Okay, little a. You guys understand so do you guys see the notation here? Big C lies opposite little c. They always lie opposite each other. Okay, and this is important kind of notation here. So a lowercase letter represents the side length. The capital letter represents the angle. Okay, guys with me on that? So the good old-fashioned Pythagorean theorem is just a squared plus b squared equals c squared, right? We all know that on a right triangle. Okay, guys with me on that? Or let me flip it around. Sometimes it's c squared equals a squared plus b squared. Okay, so those two things mean the same. That's the symmetric property, by the way, right? Guys with me on that? Now, why did I choose to write lowercase letters and not capital letters on this? Why, Wyatt? We're using the side. Now, we will this year in class get into the angle relationships. These angles actually have a lot to do with the Pythagorean theorem. We're just not there yet. That's called trigonometry, and we're going to get there, okay? Sine, cosine, tangent, stuff like that. We're getting there, but we're not there yet. Now, here's the deal. This means it's a right triangle. So if c squared equals a squared plus b squared, by the converse, this means it's a right triangle. Okay, but here's the deal. You can say more. You guys know what an inequality is? A greater than or less than symbol? So if you had another triangle, let's say you didn't know this is a right triangle. Okay, let's say you didn't know it's a right triangle. And it happened that if it happens that c squared is actually greater than a squared plus b squared, that can happen. C squared plus a squared plus b squared c squared is actually greater than a squared plus b squared, then we know it's going to be an obtuse triangle. Oh, sorry, my bad. Man, I just messed that whole up. Let's just pretend that never happened. Okay, but I screencastify it, so okay. C squared is greater than a squared plus b squared, then it is an obtuse triangle, which means this angle right here is greater than 90. Does everyone understand that? And the reason I'm using C is always the largest angle. You guys understand that? That's kind of the notation. And so what's going to happen on your, delta math, is there, I think, and who's Cody, is you've done this delta math assignment? Is right, Cody? And is this kind of what it was talking about? Yeah. Yes, Caitlin, you've done it. Okay, so does this kind of clarify it a little bit? Caitlin, do you wish I was talking about this before you did your delta math, or did you were able to figure it out okay? Okay, again, and then again, so if c squared, guys, is less than a, if c squared is less than a squared plus b squared, what do you think you have? You've got an acute triangle. So that's pretty cool. So here's the deal. The Pythagorean theorem works on right triangles, but it can also tell you information about whether you have an acute or an obtuse triangle. You guys see that? Another, and it's just going to keep coming back around. Pythagorean theorem, Pythagorean theorem, Pythagorean theorem. That's why a squared plus b squared is something kids probably know before they even know what it means. You guys see that? Okay, any questions there? Okay, so what's our learning target today is I can decide if two triangles are congruent. Yesterday was SSS, right, guys? Today we're going to talk about ASA, angle, side, angle. So now we're not just going to have, we're going to have some angle information thrown into that. And what do we always do when we do this? How do we always start this stuff, guys? We always construct. All right, so let's go ahead and construct. So I'm going to pull up my Schoology, my geometry tools so I can show it to you. I need, let's do this. Let's get this going here. Let's get our geometry tools out. Let's do it. Here we go. You also need scissors. Will, be careful. I was a little worried when you did that stuff earlier. Okay.
Yeah, Will.
This down.
No immature.
Okay. We need paper. We need paper. This road, what happened to all your white paper? I had a ton of white paper and I lost it. What happened? I'll be right back. I'm getting a bunch. Oh, I got white paper right here. It's going to be awesome. Okay. Here we go. So grab some white paper, guys. We need it. White paper's really. Let's grab 2 sheets. I have no idea what the screen casts if I can hear what we're saying right now. All right, we're back. We're getting our geometry tools, and we're going to construct some stuff. The kids are very excited about it. Even Chris. Okay. I cannot believe that. Tegan, did you put something? No. Okay. All right. She doesn't lie, so Tegan wouldn't lie.
I don't remember that. Really? 1 piece or 2 pieces?
Get 2 pieces. Okay. So let me pull up my screen and show you what we're going to do here, class. So let me get into my Schoology page. Let me pull up my construction tools. Okay, all right. I'm going to get rid of my face now because you don't need to see me while I'm doing this. All right. Okay, ladies and gentlemen, let's turn it landscape it. And what I need you guys to do is we first of all need to start the given. So the first given is let's just make an array, okay? You guys with me on that? Okay, and make the array kind of on the bottom-ish part of your paper like we normally do. And then we need a given triangle, okay? So I'm going to make a, something, I don't know, something like this maybe. I always like to make scalene just because it's a little more fun. Okay, I'm going to do something like this. Okay, here's my given triangle. Okay, so if you guys could do this and construct a given triangle, and we'll call this triangle, just to be very creative, ABC, like always. Okay. Okay, now, remember, guys, yesterday, the given triangle, what we did is we constructed it just by recreating the sides, right? And that was actually a pretty easy task. So what we're going to do today is we're going to recreate it using we're going to start with an angle, and then we're going to construct a side that's next to the angle, and then we're going to construct another angle that's next to that side. It's angle, side, angle. You guys good with that? Okay, so let's go do this. I'm going to take my compass out. I'm going to put a dot on the end, and I'm going to call that point D. Okay? You guys with me on that? So on the right side, let's say this is a ray, and that's the end point D right there. Okay? All right. So you always need a ray to start with usually when you're doing a construction of something like this. Okay. So we'll call this point D. So this is our given ray with the endpoint. Okay. So what I'm going to do is I'm going to construct an angle at D. I'm going to construct angle C at D. So it's a pretty simple task. If you've forgotten, it's not a big deal. So what I'm going to do is I'm going to take my compass. I'm going to put the needle on C. I'm just going to kind of open it up as much as I want. Here, I'm going to lock it, and then I'm just going to go ahead and make an arc here. I'm going to make an arc. And let me change the color to red. All right, so now I'm going to make an arc, and I'm just going to do that. Okay, so go ahead and do that at angle C. Keep that compass setting the same, and come down and make that arc down here at D. Okay, see what we're doing? All right. And then we're going to make this arc just like this. And we're going to kind of open it up, about a half, maybe a semicircle, half circle, something like that. Okay. Y'all with me on that? Now, next thing I'm going to do is I'm going to take my compass and I'm going to go measure this opening right here on my arc. So I'm going to take it here. I'm going to measure it. I'm going to unlock it, adjust my compass a little bit. And so I'm going to come down here and do that. Do y'all see that? I'm going to lock my compass. I'll give you a second to do that. Okay. Then I'm going to take that needle and I'm going to come down here. I'm going to put that needle right here. Then I'm going to move my compass up here a little bit. Sorry, I need to rotate my compass around. Okay, and what I want to do is I want to make a mark right here. Okay, does everyone see that? Okay, so and then I'm going to take my straight edge. Okay, and I'm going to make it in, I'm going to change the color, I think, to black here. And I'm going to start at D, and I'm going to go through that point right there. Okay, like that. And I'm just going to extend it out. It doesn't matter how long we want to express. I'm just going to extend it out. But I need to make sure, I don't think I hit it exactly. I need to make sure that goes through D, starts at D, and goes through that arc intersection right there. Okay, see that? And it can go as long as you want. Okay, question about that? Okay, now, the next thing we're going to do is we're going to measure. So we've done an angle, right? And let's just call this point right here. Well, we don't need this point. This point is not necessary right now. It's just basically we're just getting the angle. So we didn't do anything about a side. All right. So the next thing we're going to do, ladies and gentlemen, is we're gonna create this side right here. Now sides are the easiest thing to create, right? Construct. So I'm just going to take my compass. I'm going to bring it over here, and hopefully it'll stretch. I don't know if it will actually. And I'm going to stretch it. Oh, barely. Like that. You guys got it? And I'm going to lock it. And I'm going to take that needle, and then I'm going to put it on D, and then I'm going to make an arc. You guys with me on that? I'll do a blue arc. Okay. So what I've done is I've just reconstructed side CB right here. Cool with that? Okay, I'm going to move that compass out of the way, and I'm actually going to put a letter. We'll call that E, just for creativity, right? Call that E. So there is E. So we know through construction that CB is congruent to DE. You guys agree with that? Any questions? Okay, the next thing we need to do is we need to create another angle. So we're going to go over to B, and we're going to recreate B at angle E, at point E. Did you guys see that? So I'm going to go over here. I'm going to put my compass needle on B. I'm going to unstretch it. I think I'm going to go to green this time. Green's always a pretty constructing color, right? So now I'm going to go to green here. Put it on B, Mr. Roden. Unlock it. Unlock it. Okay, and then I'm just going to open it up like that. I'm going to lock it, and then I'm just going to construct. I'm going to just do that, just like that. You guys see that? Then I'm going to take it. I'm going to take that setting, and I'm going to come down to E, and I'm going to make an arc here. It'll go like that. You guys with me on that? Then I'm going to come down here. I'm going to measure this opening right here. So I'm going to unlock that. I'm going to measure that opening. I can't even really lock that because it's too small. And then I'm going to come down here. Hopefully that doesn't move. And then I'm going to take this needle here. And then I'm going to swing this around like. So I just took this opening. All I did is take this opening, measure this opening right here, right? Hopefully it didn't move. And then make that up down here. Now, if I messed up, so basically what we want is we want this thing right here. Do you guys see that? This is the point we want. So now I'm going to go ahead and construct a segment starting at E, and I'm just going to keep going. And you're going to notice if I did it correctly, it's going to look like that. See that? So now, so this point of intersection up here. Now, at first, I got a little freaked out because I wanted to go through this red one, but it doesn't need to, right? That doesn't matter. But so this up here, this is right here. This should be DEF right here. This should be point F up here. Now, let's see how well we did. So I want you guys to cut out. I kind of like what Xavier did. He only cuts out the constructed one, right? And then sees if it fits on top of the given one. So I think that's a good idea. So just cut out the constructed one and see if it fits on top of the given one. Okay, and that's always a good test for congruence. All right, let's go ahead and do that right now. How did it work out, guys? Okay. You're supposed to draw a line here and then that arc right there.
Oh my god, I can do it. Oh my god, it did.
Whoa.
Did it work?
Mine's not really gonna ruin it.
Kind of.
It fits inside of it, but
Is there some human error involved?
Yeah, that's not long.
How about the next one? Make it a little better. Yep. How many got it to work? So overall, is it workable? Yeah. Maybe we could cut down the human error next time.
Mine should have worked, but it didn't.
Pretty good. How's it working? Pretty good. Pretty good. Pretty good. What do you
It's
think?
actually
Got it?
really cheap.
Yep. All right. Now, guys, a couple things I want to talk about here. We never look what we didn't do. We never this side right here. I'll just circle it. I'm going to circle it in pink. This pink stuff. We never, ladies and gentlemen, ever measured from D to F, did we? No, it just fell into place. We never measured from F to E, right? That just fell into place. And we never measured angle F at all. So notice, guys, what we did is we only had to do an angle, a side, and an angle. Now, this is getting messy here. But one thing you have to remember, guys, is that the side is kind of in between the two angles. You guys see that? So it's very important that the angles are on both sides of the side. Okay? All right, so let's try this again. So now what I want you guys to do is let's see if we can't do an obtuse triangle. Oh, well, this was an obtuse triangle, right? So just draw a different looking triangle. Let me clear it off. So let's do on the other piece of paper. So I'm going to do an acute triangle. So how about something like this? It's acute-ish looking, right? So let's start with this triangle, and then let's do a ray at the bottom. Acute-ish, all right? And then let's call this triangle, and then let's put a point on the end and call it D. Stamp a point there, D. And then let's go ahead and call this triangle ABC. So this will be triangle A. Let's put B on top here. And C. Okay, so and this is D right here. So your job is to try to construct angle A, side AC, and angle C, and see if you can't make a congruent triangle out of that angle, side, angle. Okay, guys good with that? All right, let's go ahead and do that right now. And what I'm going to do is you guys can just ignore me because this will be on screen. I'm just going to do it again. So if you're getting confused, you're welcome I'm obviously screencastifying. But if you're a live action kid, you can just follow along with me. Okay, so the first thing that I'm going to do is I'm going to construct angle A at D. So I'm going to come here. I'm going to put my needle on A. I like blue for my first. I'm going to do blue. So I'm going to unlock my compass. My compass is so tight. How can I unlock this? Uh-oh. Got a fuse. Let's see here. Can I unlock it? There we go. So I'm gonna go ahead and I'm gonna construct angle A at point D. So I'm gonna come up here. I'm gonna put my needle on A. I'm gonna move my compass around to here, and I'm gonna lock my compass. I'm gonna put an arc. I'm gonna put an arc here with my needle on A, just like that. And then I'm going to come down here with that compass locked, and I'm going to bring it down to D, and I'm going to reconstruct that arc right there at D. See that? Now, the next thing I'm going to do is I'm going to come up, and I'm going to measure the opening of this arc right here that I made at angle A. So I'm going to unlock my compass, and I'm going to move it, and then I'm going to lock it. Okay? Now I'm going to take that needle, and I'm going to put it right down here where it intersected the arc and the ray. Then I'm going to come here, and then I'm going to come here, and I'm going to make an arc just like that. Now that's not where the triangle is going to hit. That's just where the line is going to go through, because all we're doing is we're creating an angle. We don't really have to do anything with that side length. So all I'm going to do is I'm just going to put a point at D, and I'm going to extend a line through. I won't get into I don't think I'll have to be that long. See that? Now notice, guys, we're not gonna measure anything along that new ray right there. That's because it's gonna fall into place. The next thing we have to measure is the side. We need to measure one side, so we have to measure between A and C. Okay, so let's go ahead and do that. I'm gonna put my needle on A. I'm gonna unlock my compass, and I'm gonna open it up, and then I'm gonna lock it right there. And I'm gonna change my color to rojo red. Okay, now I'm going to move it down here, and I'm going to make an arc. Now, remember, this is a side length. So side lengths are really easy. So that is a side length. So now we have angle, and now we have side. Okay, so now I'm going to come over here. I'm going to just label that as, we'll call that E. I'm just going alphabetical here. So we're going to say that this is point E, capital E right here. Okay, what have I done so far? I've done angle, side. I need another angle. So what I'm going to do now is I'm going to reconstruct angle C. Okay, and so I'm going to grab my compass. I'm going to put it on C. I'm going to unlock it, and I'm going to go ahead, and I'm just going to, whoa, what happened? Then I'm going to go ahead, and I'm going to make an arc. Okay, all right, so now I'm going to go green, verde, and then I'm going to put here, and then okay. What are you doing? Okay, get over here.
I believe in you.
Come on, I need my grabby hand. Let's go. Where's grabby hand? There it is. What? Why are you doing this? Okay, what if I did this?
Question mark. Click the question mark.
But
Click the pen. Click the pen. Now drag the pen.
I already. I've been.
Drag the black part.
what?
Hover over the black part of the compass.
Thank you. Thank you, everyone. Thank you. This is a great talk.
Right there. Oh.
Because I bet you don't do this so well.
Oh, shit.
Okay, guys, we're having technical difficulties here. So basically what you're going to do is now you're just going to reconstruct this angle here and then draw a line through there. Does that sound good? I don't really want, let me see if I back out of this. My compass is not going to move. Yeah, so just pretend like you understand what you're doing and just do C and then construct it, all right? Okay, I'm going to go around and take a look. Okay, guys, once you cut it out, check for congruence. Remember, when you're cutting out and putting it on, you're flipping things, you're turning things, you're sliding things, right? So it's called a transformation when you do that, right? All right. So once you get it, cut it out, and then check for congruence. Okay, guys? So we have kids not needing help. So guys, what I'm going to do is I'm going to close this out and let's just start over. So let's see. You could do it on any kind of triangle. Yeah. Yep. Isn't that cool? Mr. Roden's going to close this out. He's going to go to construction tools and start over. First thing Mr. Roden's going to do is draw a line because he messed up. And then he's going to draw an acute-ish looking triangle. Something like this. Okay. Next thing Mr. Roden's going to do is he's going to take his compass and he's going to stamp a point here. We're going to call that point D. Okay. And then we have ray D. Guys, if you don't understand, I'm going to do it over again here. So this is A, this is B, and this is C. Now, there could be some human error involved with this. That's okay. So we are human beings. So now the first thing I'm going to do is I'm going to reconstruct angle A at D. So I'm going to come over here. I'm going to put my needle on A. Let's change it to red. And now I'm just going to open it up a little bit, lock it, and turn it. Lock it and turn it. Now I'm going to come down here. I'm going to do that same thing with that same setting, and I'm just going to make an arc like that. Now I'm going to come up here. I'm going to measure this distance from here to here. I'm going to unlock, and then I'm going to lock. I'm going to come here. I'm going to come down here. I'm going to put my needle there. I'm going to rotate around like that. Oh, I don't want to draw, though. Undo that. Okay. And then I'm going to come here like that. I'm going to come around here like this. I'm hearing good things out there from students in the class. That's good. Then I'm going to move this compass out of the way. Then I'm going to put a line through there. Now notice this segment right here, guys, can go as long as we want because we're not measuring that side D whatever that's going to F, right? All I did is just made it go through that intersecting. Now we're going to go ahead and measure. We're actually going to construct side DB. So I'm going to put the needle on A. I'm going to unlock the compass, and I'm going to move it, and I'm going to put it on the B. And then I'm going to lock the compass. I'm going to change it to azul for blue. And then I'm going to come down here, and then, or in French, bleu. And then I'm going to go ahead and do this. I don't really know if that's how you say blue in French. Okay. All right. Now, next thing I'm going to do, I'm going to move that off to the side, and then I'm going to go ahead and write FDE right here. This is side E. Okay. And then now this is where I went wrong the last time because my compass got stuck. I'm going to come over here. I'm going to reconstruct B at angle E. So I'm just going to come up here. I'm going to put my needle on B. I'm going to unlock. I'm going to switch to green, verde, and then I'm going to go ahead and green in Spanish, in French, and then I'm going to do this. And then I'm going to go like this. Okay. Then I'm going to do that. That. Let's do something like that, right? That. Now, then I'm going to measure this opening right here, from here to here. I'm going to unlock it, measure that opening. I'm going to lock. I'm going to come down here. I'm going to put my needle right here, and then I'm going to do that. Okay, now I should have constructed angle B. Let's move that off to the side. Let's do that. Let's see. And now that's all I need. So it should, if I did it right, be congruent. And notice I didn't do anything with any of these other sides. So this is F right here. So the only thing I had to do is angle, side, angle. This is A, S, A, where the side is in between the two angles. Okay, ladies and gentlemen, how's it looking? Pretty good? Is it human error or is it understanding?
It's human error.
Okay, yeah, we're not gonna judge human error. So can we pretty much agree that if we have an angle and a side that is sandwiched in between them, we can make two triangles congruent. You guys agree with that?
Yeah.
Okay, here's what I need you guys to do. I need you to put geometry tools away. I need you to have your notes ready to go. Recycle anything. If you want to keep the triangles, great. If you don't, just recycle everything you don't want. Put everything away in a little packet, Will, there it comes forth. And let's get ready to kind of make some knowledge of this, okay? Okay, so what I'm going to do now is I'm going to switch my screen over here, and this is what we've talked about today. Angle, side angle, congruence, triangle theorem. Now, the book that I got this out of here is calling it a theorem. We're going to kind of do it in a little different order, and we're going to call it a postulate. So I'm going to mark this out. So this is angle, side angle, and we're going to call this postulate. Postulate. So you can prove this if you kind of do it in a different order of the way we've been learning. But this is angle, side angle, postulate. Okay? So I'm going to have my class copy this down now. So quick guys, here we go. So write this down. Angle, side angle, congruence. Now, are we ever going to say, we're always just going to say ASA, okay? And here's what it says. If two angles and an included side of one triangle are congruent to two angles and an included side of another triangle, then the triangles are congruent. So we do not, again, remember when we first started this whole fun, we always had to have our 6 things. We had to have 3 angles and 3 sides. And then we had a student in here who kind of figured it out that if we know just the sides, we don't need to know about the angles. But here today, what we've learned about is if we have 2 angles and a side in between, we actually can construct congruent triangles. And it'll always work. But it's a postulate, okay? It's just as true because it's true in this class. All right, so what is this saying here? So if I have 2 triangles, ladies and gentlemen, okay, and I'm just going to draw 2 triangles. If I have 2 triangles, and I'm just going to draw really basic triangles, I'm going to keep it kind of equilateral-ish looking, but I'm going to copy and paste just for fun. And I'm going to come over here and paste, okay? So if I have 2 triangles, and this is what ASA is saying. If I have 2 triangles, okay, and if I know that if this is triangle ABC, and this is triangle DEF, and I'm given, or I can deduce, okay, deduce if I can use other things I've learned. If I know that I have an angle here and an angle here, let me do that in red. If I know I have an angle B, in this case, an angle E are congruent, and I know for some reason, whether it's a construction or something I've done or it's a given, that BC and DF are congruent, and I know that angle C, and I'm going to put 2 arcs here because there's maybe B is congruent to C, but let's pretend it's not. If C is congruent to F, then I now can say these 2 triangles are congruent. Okay, I don't need to know any other information. I don't need to know any information about the other sides or angles because we've constructed it. We've kind of confirmed this through constructions that now we can say triangle ABC is congruent to triangle. Now, notice how I numbered this. I started with A, I went down to the 1 arc and ended at the 3 arc. So you always want to do that same order. So if I start at D, the no arcs, right? Then I go to E, then I go to F. So then I go to E, then I go to F. So I can say these 2 triangles are congruent by ASA. Okay? So that's pretty cool. So another cool thing is we can say triangles are congruent without having to have all 6 pieces of information using the definition. Remember, the definition of a congruent triangle is 3 congruent corresponding angles and 3 congruent corresponding side pairs. Okay? You guys see that? Okay, so how can we use this? So what I want you guys to do right now is go ahead and copy down these 2 problems. And they're totally out of order. I'm sorry, because I just copied and pasted them out of a book. All right, so let's copy these 2 things down and let's determine whether these things are congruent. And what we're going to have in our head today, guys, is ASA. Now, don't worry, SSS is still around. We're going to come back to it. We're going to put it all together in a big pot and mix them all up and start seeing if we can't pull stuff out. But right now we're just developing them. And I know a lot of you really like SSS. Don't worry, SSS is here to stay. But today we're just focusing on ASA. Okay. So go ahead and copy these down and let's take a look at them. All right. Now, if we're looking at this triangle right here, right? We're looking at this triangle right here. Well, can I say that triangle, let me see it, is triangle, there's triangle A, B, D, is that congruent to triangle? Now notice I have to go back to A, triangle A, C, D. See what I did? I went no arc, one arc, and then this is also, can we say that's a right angle right there, guys, by angle addition postulate, right? Can't we? That's a deduction, right? We can deduce that. It didn't give us that's a right angle, but we know it's a straight line, guys. So here's a geometry thing. We only have to put this right angle, and we can assume the other side's a right angle, right, guys? You guys with me on that? Okay, so can I say these two triangles are congruent? Well, yes, because if this is also a right angle, I can say these two triangles are congruent by angle, side, and right angles are always congruent to each other. You guys understand that? Angle, side, angle. And I'm done with this. Okay, guys with me on that? Now, let's look at this example. Can I conclude that these two triangles are congruent?
No.
Well, is this going to be 67 degrees also, if we do the math? If we add up 38 and 72, is that going to be? No. So, by the way, we already know that, but let's just not even worry about the angles. So, why are these not going to be congruent by ASA, guys?
Because I actually know.
Oh, wait a minute. We're going to have to know this angle. Let's someone do the math for me. What's 180 minus 38 minus 72?
It's 70.
What? 10, way too.
Those two added up are 110, so 70. It's 70.
What? So this. Okay. So we all agree that R is 70.
Yeah.
We all agree R is 70. Okay. Now look. What do we have? We have a 38. We have a 1. We have a 1 in between a 38 and a 70. Right? Guys, see that? So this is congruent here, and this is congruent here. You guys see that? So we have angle. We got a side. These two sides are congruent. But what do we not have, class? This angle here is not congruent to this angle here. So we cannot say ASA does not work on this because this angle right here doesn't work. We have AS, and then we're done, right? So we have to have ASA for that. So this is a big old fat no. Cool with that? Okay, so yes on this, no on that. Happy, good. Happy, good. ASA, good. ASA, good. ASA, good. Good, ASA. No ASA, bad. Bad, no ASA. No ASA. You guys understand that?
That's an arm.
Bad. Bad ASA. Very bad. Okay, all right. Now, so your job right now is, let's do 3 and 4. Those are actually numbered correctly. I want you to copy these down, and then we're going to just kind of talk to you guys in a minute. Copy these down really quick and decide whether you have ASA congruence or not. Go. And it looks like they've been translated, they've been rotated, they've been reflected a little bit to try to see if you're paying attention, right? Here's a hint. You're going to need to know the angles probably on all the triangles, right? Oh, no. Oh. And by the way, guys, I've told my live action kids today that I'm going to be grading I'm going to be putting in all the corrections. And I like that you guys are giving me on hard copies and not emailing them to me. That way I can just all grade them in one piece. And then I'm going to also grade your booklets today. So look for that in Power School today. I'd say by 7th period, guys, you'll have that all in there. I have a question from the class. Yes.
I still have to turn in my corrections because I have one part still to do classroom.
Let's make corrections due by tomorrow at end of business. Does that sound good? But I want to put the corrections that are done in today. Does that sound good? So you guys can have like ice cream or something after school if you have good grades. Yeah. For your parents. Okay, so before we do this, guys, let's talk. I always kind of want to find that corresponding side. So, guys, it looks like I'm going to need this side right here. What side corresponds to JL in its MP? So that's the side that we want to probably take a look at. Is that okay, guys?
Yes.
Now, the reason I'm doing that is because with triangle M and P, I have M and P. I got two angles and a side. So I don't have to do any work on this triangle. You guys see that? But I will have to, what angle am I going to have to find up here, guys, to worry about ASA? I got to find L, right? Now, I do have a student next to me. I don't want to mention his name for identity purposes. This student next to me, what do you have for L?
50. No,
Okay.
It's 30. It's 30. So.
This student is saying 30. Live action kids, do you agree with his answer of 30? Yes or no? Yeah? Okay. All right. Enough kids, I think, are agreeing with him. We're going to go. So, mystery kid, can you tell me, are these two triangles congruent? Yes. Why are they congruent?
Because ASA.
They are congruent by ASA. So I can make a statement. So, mystery kid, what triangle? Let's start with the bottom triangle. Give me some letters.
NPM.
NPM is congruent to what?
KJM.
You went N, you went no degree to 30 to 29. So you want to go
KLJ.
KLJ. You guys agree with that? Triangle KLJ.
That's what's the first time.
You did? Okay. And why can we say that, mystery kid?
Because ASA.
ASA postulate. You guys see that? What about this one right here? What do you guys think about this one right here?
No.
Well, this is a big fat no. Why, guys?
Because just looking at it.
Well, yeah, but we don't go by the looks in geometry. We go by what angle is. Let's look at F really quick. What is it? Oh, so we got to look. So it looks like in this one, we're going to have to use this side here. So EF has to correspond with BC, right? So we got this 68 here and 68 here. So what's this F going to have to be in order for those two to be congruent, guys?
33.
Is it 33?
No.
What is it? What is it? This is 31, ladies and gentlemen. So they are not congruent because these two angles are not the same. So again, this is a bad, no congruent, no bad, not congruent, no ASA, no ASA, no SA. Okay, angry monkey. Okay, let's do one more problem here. Okay, okay, let's try this one. Everyone draw this out. We're going to do a proof together, okay? Proofs are fun. Okay, proofs are really fun. So write this down. Okay, so write this down. This is going to be a really, really, really fun proof. Now, have we talked about angle bisectors in here, class? We have, and that is really good because we've talked about angle bisectors in here. Okay, so I'm going to make a proof, okay? And what I'm going to do is I'm going to use the picture as a visual aid, but the proof is going to be a two-column statement reason proof. Okay, so I'm going to do this. Make a straight line here. Let's make that, okay? And then I'm going to make another line here, and I'm going to just do S and R, okay? Statement reason. Okay. Oh, I don't know what happened there. Okay, so now this is statement, and this is reason. And I'm actually going to number my lines. Okay, so first thing I'm going to write down something, and then let's see if you guys can help. I'll write the statements. You guys give me the reasons. So I can say this, that, okay, here we go. I can say that AB, segment AB bisects angles CAD and CBD. Okay, so that's my first line. That's line one. What's my reason behind that, guys? What's my reason? Yep. It's a given. Yep, so this is just a given. That's just a given statement. Okay, now here's the next statement. Okay, this is step one. Okay, now here's step two. So knowing that, if AB is a bisector, then I can say that C I can say CAB is congruent. CAB is congruent to angle DAB. Angle DAB. Okay, so look here. I can say that these two angles are congruent. Why can I say that? It's the definition of a bisector. That's what bisectors do, guys. They split angles into two congruent angles. So this is the definition of a bisector. Okay? That's what bisectors do. They create two congruent angles. Now, the next step is I think I can do the same thing on the other side. You guys see that? I can say that angle CBA is congruent to angle DBA. And why can I say that, class? Live action, why can I say that? It's the definition of a bisector. So this angle here is congruent to this angle here because it's being bisected by side AB. Did you guys see that? So what do we have? We have an angle and an angle. What are we missing, class? Do we have a side? We have side AB in between, right? So now I can say this, step 4. I can say that side AB is congruent to side AB. Side AB is congruent to side AB. Why can I say that side AB is congruent to side AB, guys? Yep, they're the same line. So what's the fancy smarty farty way to say that? Rachel, what do you got? That's the reflexive property. That's the reflexive property. I'm running out of room and I want to be able to see my picture, so I'm just going to extend this down. So step 5, ladies, hold on, let's just finish this. Trust me, guys, you never leave a proof unproofed, right? So proven. Okay, now guys, we wouldn't be able to sleep at night if we did this. I'll be fast. I can now say a triangle congruent statement. I can say angle A, triangle angle A, C, B is congruent to triangle A, D, B. Why? ASA. ASA is the reason. Angle, side angle. And I'm done. You guys see that? That is amazing. Guys, I'm going to stop sharing now. Have a great day. We'll see you later. Bye.